So we'll start the recording. That's through more down here, and this is a Zoom bar, right?
Right.
Okay.
And somewhere there should be a little blinking red light showing we're recording.
Right. Yeah, it's right here.
Yeah.
Yeah. Okay. All right. Can everybody see okay?
Yes,
I'm sorry?
I see the screen here.
Okay. Want to make sure everybody could see it. Okay, so feed lines and connectors. So we've discussed the antennas, but somehow or another we have to get the information from the antenna to our radio. And we do that through a series of feed lines and connectors. Feed lines are used to connect the radio to the antenna. The types include coaxial cable, which is the most common, but there are other types such as ladder line, twin lead, and open wire feed lines. You don't. Sorry, ma'am. Oh, okay. Open wire feed line. I've never really seen an open wire feed line, but I have seen ladder line and twin lead. Coaxial cable is the most common type because it's easy to use. And don't you believe that statement that says no special tools required? It is possible. I mean, there's companies out there that will build your coaxes to the coaxial cables to the length that you want with and terminate them on both ends with the connectors that you want, but you do pay a premium for that. And if you're doing it, if you're going to be doing that for more than one radio setup, generally it might be better to just buy a few simple tools and you'll be prepared to build your own anytime you want.
Can't you just use an angle cutter to cut it all to length?
I'm sorry?
Can't you use an angle cutter to cut it to length?
You can, but then you do have to re-terminate it. You have to
What do
put
you
a
mean by
connector.
terminate?
You have to put a connector on the end of it. Unless you're soldering directly to, I mean, you have to put a connector on the end so that you can screw the connector on to whatever radio or antenna you need to screw it onto. But yes, you can use an angle cutter or electrician's pliers to cut the length that you want and then put your connector on it. Some people are nervous about putting on the connectors, and there are different types. Even with just a PL259, there are different methods to install it. You can use a solder connection, you can use a crimp connection, and a crimp connection, you're still most likely going to be soldering a pin on, or there is a compression type. Now, the compression type fittings are a little tougher to, well, they're more expensive, but they're actually fairly easy to install if you have a pair of pliers or better yet, a wrench. But anyway, so coaxial cable is the most common type, and because it's easy to use and easy to get where you need it to be. So here's a few different types of feed lines right here. You'll see the first one. The first one here. That's your coax type. So you'll notice that in the coax, you have a center core, a center conductor, and then you have a dielectric insulator. And then you have, so center core here, dielectric insulator there. And then this is a metallic shield. Some coaxes, some of the coaxes used for like cable TV and satellite TV will use a metallic shield, which is braided. It's braided. Copper is better, but sometimes it's braided aluminum or copper or tinned copper. But then some of the television type connectors, they will also have a foil that's wrapped around there as well. I'm not really sure. Well,
Yeah, some of the better coax also has double shield, foil
Yeah.
and braid.
foil and braid. And then you have the jacket. The jacket is important to pay attention to based on how you're going to use it. If I bought, 30 feet of LMR 400 times microwave LMR 400. That was, LMR 400F was the final designator in the part number. And I bought 30 feet of it and thinking, okay, I can use some LMR 400. I bought it at work. But I didn't know off the top of my head what the F was all about. I had to look it up when I got home, and I found out that the F means that the jacket is fire retardant, which required for aircraft installation. It has to be fire retardant. The problem with the F is that it's fire retardant. It doesn't burn, it doesn't give off gases when it gets hot, but it doesn't like ultraviolet. So I can't put it outside at all. It's only going to be used for jumpers indoors. So you do need to pay attention to the designator for the jacket. Some jackets are going to be designated for direct burial. Other jackets are going to be designated for ultraviolet protection, which is important. That's what you're going to be looking for if you're outdoors, is you definitely want it to resist ultraviolet. Anything to add?
Direct burial?
Yes, I did mention direct burial. Just because it will resist sunlight doesn't mean it's going to resist the critters in the sand from getting into it.
Basically, you need to make sure that you don't get water into the coax. It changes the dielectric and can really have a drastic effect. Plus, if it's braided shield, it tends to cause that to corrode if it gets water in it.
Okay, and then we've got the second type here. I think my 1-year-old grandson can do better than that with a tube. But I'm doing it with a mouse, so. But anyway, this is ladder line or twin lead.
Sometimes a window line.
I'm sorry, window line. Ladder line is different. This is window line on the top there, and then twin lead at the bottom. Twin lead was used a lot in television days back before coax became so common. But I think twin lead is 75 ohms, right?
No, 300.
300.
You can make a J pole out of 300 ohm twin lead.
Okay. And then over here, let's see. Look at that. Much better 3. This here, we actually discussed this not long ago at the club. This is hardline. And this is what you want going from, like if you set up a repeater, the club's talking about maybe getting a new repeater. And when you run the line from the radio at ground level to an antenna 200 or 300 feet up a tower, you need something that's very protective. So this stuff resists
low loss.
Yes, very low loss. So yeah, this is the type of coax that we would use for that. And you can see it's not real flexible, so it requires special tools and special techniques to be able to install it. And did you all look in the middle of there? So this is air dielectric, right?
Yes.
Yeah, so and this is good cable here. But anyway, yeah, that's a major expense of setting up a repeater, as it turns out, because this stuff doesn't come cheaply.
And that does require special tools.
Yes, and techniques. Let's see. Okay. And you heard me say ladder line a minute ago, but that wasn't ladder line, that was window line. Bob caught that and corrected it. But this is what your ladder line looks like. And I've heard of people making their own ladder line before. It looks like a lot of work to me.
Depends how long it is.
Yeah. But you see it's 600 ohm, and I'm guessing the 600 ohm is based on how far apart it
Right.
is.
And it's several inches.
Yeah, it's not simple. So there's another type.
So on that On that ladder, the black pieces, those are just insulators
Yeah,
to separate.
It's separate.
Yeah, that looks like, in fact, I think I can see writing there. That might just be
Like
some-
ABS
some-
or
some type of hose or something like that. I don't know. But yeah, it's just an insulator to put between them to keep them fairly just, yeah, consistent distance apart. The important parameter of a feed line is characteristic impedance. So I've got a box with probably 150 or 200 feet remaining of 1 gigahertz line coax cable RG6 for running cable TV and satellite TV. And of course, that's 75 ohms. So I'll never use it because it's not what I need. And I don't pay the cable company anymore. So anyway, you want to pay attention to the characteristic impedance of the transmission line that you get for your radio because you need it to match up to what the radio expects to see. The radio's output impedance is 50 ohms. So you want to make sure that your coax cable is 50 ohms. Now, those other types of feed lines are not 50 ohms, so you have to somehow or another match them.
That's where an antenna tuner comes in, but it doesn't tune the antenna.
Yeah.
It's a matching network.
Impedance is the opposition of AC current flow. Remember, I think we discussed resistance, and resistance resists AC and DC current flow. But with regards to impedance, it's still measured in ohms, but it is an opposition to AC current flow, and it has a tendency to change based on some of the variables there. Yeah. So you see that impedance is indicated with that's a lowercase z, right?
I think it's capital.
Capital. Oh, okay. So you've got Z is
Equal to the real resistance.
yeah.
Plus the reactance, and you have inductive and capacitive reactance.
Yeah. There's a lot more on that in the extra exam. A transmission line terminated in its characteristic impedance appears as that impedance at the source. Feed line impedance should match the transmitter output and the antenna input for maximum power transfer. What happens when you get like if you've got output impedance of your antenna or of your radio is 50 ohms and your antenna is 50 ohms, but your feed line between them is 75 ohms, you're going to lose power through that 75 ohms. Even if you use your antenna tuner to make it appear correct to the radio, still not correct, but it appears correct to the radio, you're still losing power through that mismatch of impedance at both ends.
The one thing about transmission line with the characteristic impedance, like I said, how they determine that is if you had an infinite length of it, and you measured it, it would, what that impedance you see is its characteristic impedance. Obviously, you can't have a piece infinitely long. So if you have a shorter piece in the real world and you terminate it in its characteristic impedance, that's what it looks like if you measure it. So that's why it doesn't matter the length of the transmission line as long as it's terminated in its characteristic impedance.
Okay, first question of this section. Why is coaxial cable the most common feed line for amateur radio antenna systems? Alpha. Does everybody agree on alpha?
Everybody but you.
Yeah, I was.
No, it's correct. Easy to use because it requires few special installation considerations. Like I said, the considerations are just basically making sure that the characteristic impedance is correct and making sure that the outer jacket is going to satisfy your installation. But other than that, it's fairly simple to use. Oh, one of the things that might be worth mentioning is that different types of coax have different bend radiuses. Okay, so how far can you bend it safely? And what you'll find is that what I've noticed is that if it's, temporary use, the bend radius is always less. If it's a permanent installation, you can build it a little more. And the reason for that is that you're not doing this. You're not constantly bending it one direction or another, which causes, I guess the big thing with that is the dielectric.
The
So,
center conductor can get closer to the shield, so
Yeah.
it changes the characteristic impedance.
Yeah. That's one of the reasons I put up my Diamond 50 to test it. And was thinking about leaving it up and then decided to take it down because it was just moving around too much and I didn't want to damage the LMR 400 that I have. The LMR 400 that I bought to put that antenna up. I bought 75 feet of it and it's the correct one. But I didn't want it moving around a lot, so I wanted to wait until I got a better install method. So, okay, so what is impedance? Alpha, opposition to AC current flow. What is the unit of impedance? So how is it measured? What
Delta.
delta? Very good. Still in ohms. Feed lines and connectors. Most amateur radio transmitters have an output impedance of 50 ohms. All of them that I've seen have an output impedance of 50 ohms. Most antennas have an input impedance close to 50 ohms. You notice it says close. Either directly or with a matching transformer. So your in-fed half wave, your in-fed random wire, your 17-foot verticals all have to have something to match them up in order to have the proper characteristic impedance. Most coaxial cable used in amateur radio stations has an impedance of 50 ohms. RG58 and RG213 are often used in amateur radio stations. Both have an impedance of 50 ohms. And I don't have any 213, but I do have a jumper here that I brought in. It's 58. And that is probably the least expensive coaxial cable you'll find for use in amateur radio. And I use that for all of my HF stuff currently.
Typically, you use it for like patch cords, like in your ham shack to connect up your radio to a tuner or watt meter or whatever, because it's flexible, it's cheap, and in short lengths, it's not too much loss. It's much lossier than the half-inch type cables like 213.
Yeah, that's very much.
What is this one?
It's equivalent to 213. It's
Okay.
probably RG8 or
Okay. Oh, and you notice it's terminated both ends with PL259s. Let's see. Now, pay close attention to this chart. There's a couple of things I want to point out on here. You'll notice that it's got a star next to RG58 and RG213 so that you can compare those values as you go down. The other thing you're going to notice about this chart is that regardless of the cable, as the frequency goes up, let's see here. Okay, you'll notice that as the frequency increases going down here from 3.5 megahertz to 2400 megahertz, as the frequency goes up, the loss goes up for every type of cable. So that's a characteristic of frequency. And I've got theories about why that is, but I haven't actually looked it up. So you'll notice when you look at RG58 there at 3.5 megahertz per 100 feet of cable, you're losing 0.8 dBs. And RG13 or RG213, I'm sorry, is 0.3 dBs. But you'll notice that each step in the frequency range, you're losing a little bit more and a little bit more. There is, let's see. Okay, so right here, you'll notice 144, you're almost double from on RG58. You're losing 5.5 dBs for every 100 feet of cable in the 2 meter range. When you jump up to the 70 centimeter range, you're almost double that. Remember that every 3 dBs is half of your signal strength.
So 5.5 is almost 6, which is a quarter.
Yeah, so you'll cut it in half once and then cut the remaining part in half and you're down to 1/4. And then you're gonna go up what's that? 2.5 dBs again. I'm sorry, 4.5 dBs again. So yeah, you're cutting down to you're close to 13 watts out of your 13 watts out of a 100-watt transceiver at that point. So you quite a bit of loss. And that all that power that's going away is going away in heat, right? So, and anyway, let's see, let me get this back to regular use. So what is the most common impedance of coaxial cables used in amateur radio?
Baker.
Baker, that is correct. 50 ohms is the most common characteristic impedance. What happens as the frequency of a signal in coaxial cable is increased? So as we're going up in frequency, what happens to that signal in your coax cable? The losses increase. That is correct. What is the electrical difference between RG58 and RG213 coaxial cable?
Charlie.
Charlie. So RG213 cable has less loss at a given frequency. Will the chart be available when they take the exam, or do they just need to remember that?
They'll need to remember it. No, they don't get that chart.
Okay.
The only diagrams you get on the exam are the ones about components.
Yeah.
Where, what is figure 1, what is figure 2 type thing.
So the question is, you said that the RG58 is more use, but 212.
No, it's
common, but the 212 has less loss.
the 213 has less loss. I use RG58. Most people don't. I use it because my wife looks at my checkbook.
Oh. So the
But
212 is more expensive.
for long lengths, you wouldn't use RG58
Yeah.
because of the loss.
Okay.
It's one of the basically half-inch
So
cables,
depending on how long you're gonna,
and the frequency range.
okay.
Definitely, if you're talking VHF and UHF, you want to use the big stuff.
Yeah.
Okay.
Yeah, you definitely Yeah, you gotta have something bigger because you'll lose at like, I pointed out that you're losing 3/4 of your power just using RG58 for 2 meters. So your 100-watt radio is now only delivering 25 watts to the antenna at that point. So frequency is a big player in that.
Your RG58 at UHF was down basically 10 dB.
Okay.
That's a tenth of it.
Yeah. All right. So a little bit better cable is always better if you can swing the cost. Like right now, I mean, I say my wife looks at my checkbook, but yeah, it's really something else that causes that because we were doing fine 3 years ago. But yeah, so I have to be a little cautious on the spending. So yeah, and so everything that I use, I only use RG58 right now. I'm probably gonna, if I ever, when it comes time to replace it, I'll probably get something a little better. Hopefully things will be in better shape by then.
Like what is the cost difference between them? Is it twice the price?
I just bought 100 feet of RG58, bare RG58, not terminated. I think I gave $47 for it. But so that's less than 50 cents a foot. The better cables, what is
HRO, I've used it a lot, has an LMR 400 sort of equivalent by Davis. It's their DR 400 or something like that, at about $1 a foot. So it's about 2 to 1. Now, the real LMR 400 by Times Microwave is probably 250 or $3 a foot.
unless they use it where you're working, they're willing to sell it to you at market value or at wholesale
There you go.
wholesale costs. And like I say, I got 30 feet of it for like $1.14 a foot. And that's got an expensive jacket on it. But it was bought for a job. They had 30 feet left over and I offered to buy it and they said, sure.
Nice.
So
So on the VHF, you need a 213 cable, right?
you need a better cable.
Something like that.
213, 400. What is this? Would this work for VHF?
Yeah. That's doesn't have only get part of the marking. I think this is direct burial, something like RG8. Feels like the direct burial jacket.
Yeah.
Might be what was on the chart as Berry Flex. Did it have a solid or stranded?
It is stranded.
Yeah, that's Berry Flex.
So now that's what we was talking about.
Yeah, in practice, using RG58 coax as a feed line for an 80-meter dipole might be just fine. You don't want to use 50 feet of RG58 at 440 because you lose 90% of your power. Yeah. So RG213 coax cable is not the best choice for use at VHF and UHF frequencies. Air insulated hardline, which is what this is, has the lowest loss, but it also has
Highest cost.
highest cost and a lot of insulation considerations. Most repeaters, for example, use the air insulated hardline coax cable for the feed line. So because you're going up, the radio is in a shack at the bottom of the tower, and then you're going 150, 200, maybe 300 feet up. KSC, theirs is on top of the assembly building.
You have to go 30 feet.
Yeah, oh, I was wondering if they had a room up there.
Yeah.
So yeah.
Penthouse.
Quick question. What do all these RGs mean? Like, what's the difference between RG58 and RG213?
Cost and performance. Let's see, hold on a second. Let's see, we're on slide 20. Let me go.
I think you'd probably use arrow keys instead of right click.
What's that?
Probably use arrow key to the left to that instead.
Okay,
Yeah,
thank you.
like that.
Okay, so you'll see here when you look at RG 213. RG 213 right here and RG 58 here, you'll notice that the 213 has significantly better in losses. So it's way less. So if you're looking at a 10 megahertz repeater, RG 58, you're almost losing half your power at 10 megahertz because it's 2.4 dBs reduction, but you only have 1 dB of reduction on the 213.
So why would anybody use things like RG8X?
8X has a niche following for certain applications. Is that the one that's very, very
It's very
flexible?
flexible. It's
Yeah.
better than RG 58.
Yeah. Yeah, RG8X is again, it's a little more pricey than 58, but it's also much more flexible
And less loss.
and less
lot
loss.
of-
Yes.
Not a lot, but significant.
Yeah. So did that answer your question?
Yeah, I was away for 7 minutes breaking looks.
Okay. Okay, so back to where we were there. Slide 20. So, okay, we did cover that. Which of the following types of feed line has the lowest loss at VHF and UHF?
Alpha.
Okay, 50 ohm flexible coax would have less loss within some aspects. But
Yeah,
we're looking for a different answer on this one.
that beats Charlie.
Charlie, that is correct. So the air insulated hard line, that's what's used for putting up most repeaters because of its very low loss. Many factors can cause losses in a coax feed line. And as we discussed just a few minutes ago, water intrusion, because it changes the dielectric. And that's one of the things you need to take into consideration if you're using, if you plan to bury your coaxial cable. That's an important consideration because water will get into it. Now, water will also get in at the connectors. So if you're doing a permanent insulation and you're not using N-type connectors because of their expense, then you need to wrap it, which is what I do. So I use plumbing tape, it's a thick rubber.
Electrical tape?
What's that?
Electrical tape?
You can use electrical tape. You wouldn't want to use it for a long-term thing, but like if you're putting something up that you're going to have up for 3 or 4 days, you can use that. Otherwise, the heat here in Florida, I'm not sure where you are, but the heat here in Florida would get to it. So like on field day, when we put up antennas at the clubhouse, when we put up our dipoles, we do just use electrical tape to wrap them because it's only going to be up Friday, Saturday, and Sunday. But if like a permanent installation at my house, there's this rubber plumbing tape that self-adheres to itself, and I use it to wrap all my connectors because when it's time to take it off, that comes off easily, but it won't deteriorate from weather, or at least it won't deteriorate rapidly from the weather.
Yeah, you can buy special tapes from ham radio supply places, or you can go to Home Depot or Lowe's and get some 3M. They've got about 15 different varieties. One of those, and I can't remember the numbers, is a rubber type that's self-sealing. However, it's not UV protected, so you need to cover that with the normal electrical tape that will handle UV. So it really takes 2 layers. And in fact, I've learned from practice, it really takes 3. You put regular electrical tape on, you put the rubber on top to seal it, and then you cover that to protect it from the UV so that when you go to disconnect the connector and you cut it off, it comes off. If you put the rubber type tape directly, it's a mess. It sticks.
So actually you wrap it 3 times?
I do, but you definitely need to waterproof it with some sort of self-sealing tape and then protect that from the ultraviolet if it's outside with a tape that is UV tolerant.
We've also got high SWR, but we've all discussed that already. Reflected power, power is reflected back toward your transmitter. It gets dissipated in heat throughout the transmission line. Multiple connectors in line. And this is probably a bigger problem at higher frequencies, but every connection, every place where you have a connector, there's some amount of loss there. Now, when I was doing satellite system and cable installations, every union was a 2 dB loss, which is pretty significant. And then you have people come out and want to, find a damaged piece of cable, and instead of running a whole new cable, they want to cut the damaged piece out and connect it together with a union, and that's just not a good thing to do, especially if you get 2 or 3 of those in line. You're losing a lot of juice. But multiple connectors in the line will cause loss and mismatch. Loose connectors will cause loss and a intermodulation distortion. Okay, IMD, intermodulation distortion. A characteristic of a loose connector is when you have, and I think I might have to replace a coax in my Jeep here soon because of this, but a loose connector, you'll hear static intermittently when there's not anything going on. You'll just hear it static pop up and go away.
But it can actually act as a mixer, which we'll get to in another class or so, and re-radiate on different frequencies, sum and difference of frequencies. So it can actually act like a little, almost like crystal set transmitter. Rust will do it.
Which of the following is a source of loss in coaxial feed line?
Delta.
Delta. All these choices are correct. Water intrusion into coaxial connectors, high SWR, multiple connectors in the line.
Occasionally you get one where all these are correct.
Moisture contamination not only causes higher feed line losses, but moisture can also cause coaxial cables to fail. Moisture can enter via cracks in the outer jacket caused by ultraviolet light, or it can get in through the connectors like we just discussed. Air insulated hardline is also susceptible to moisture problems, and this is one of the reasons why this has very specific installation considerations. So you think it has to be protected. Hard lines require special techniques to prevent moisture from getting into them. Which of the following causes failure of coaxial cables?
Alpha, and what does solder flux do again?
Solder flux is it's usually made of rosin, And it's usually in either a liquid or paste form, and you put it on electrical connections before you're going to solder them. What solder flux does is when you apply heat to it, it basically just prepares the surface of whatever you're soldering to receive the solder.
Kind of cleans it and deoxidizes it, so the solder will make better connection and flow better.
Flow is important when it comes to soldering. Which requires heat, by the way, and heat is not friendly to some of the connectors that you find on Amazon. Okay, so so everybody was looking at A, right?
Alpha.
Alpha. Moisture contamination is probably moisture contamination or damage to the outer jacket causes moisture contamination, but if you damage it bad enough, you're damaging other parts in there too. And that is the primary cause of coaxial failure. Why should the outer jacket of the coax cable be resistant to ultraviolet light?
Delta.
Bravo.
Ultraviolet light can damage the jacket and allow water to enter the cable. So you do need to keep an eye out for that. By the way, somebody said Delta or Bravo there, I think. Ultraviolet light can increase losses in the cable's jacket. It increases losses, but because water gets inside the cable and into the dielectric and can also cause corrosion on the shielding. What is a disadvantage of air core coaxial cable when compared to foam or dielectric types?
Charlie.
Charlie, that is correct. It requires special techniques to prevent moisture in the cable. Okay, so we're up to the takeaways. Impedance is the opposition to, where's it at? There it is. Okay, impedance is opposition to AC current flow. And the unit of measure is ohms. Feed lines. Coaxial cable is easiest to use and no serious special installation requirements, just a few simple things to keep track of. 50 ohms is most common. Losses increase with frequency. RG13 has less loss than RG58. Air insulated hard line is lowest loss at VHF and UHF, but requires special tools and considerations to install it. Let's see. Loss increase with frequency and sometimes caused by water and connectors, high SWR or UV damage. And the UV damage, of course, is it lets the water in. You want to keep the water out. Just like electronics, keep the smoke inside the unit and you're much better. And let's see.
This last one, or we got one more?